谢谢大家。
感谢周凯龙先生带来的精彩分享。有越来越多的企业开始将 AI 纳入他们思考未来战略问题时的可能性合集中，但 AI 技术从论文到实践，从有解决问题的可能到能够解决问题之间的距离，一直都是对行业和需求理解深度的考验。接下来将要给我们带来分享的这家企业，一直专注在新能源、零售这类全球化程度比较高的行业场景中，探索计算机视觉的用武之地。在技术落地的过程中，他们有些什么样的深入观察和思考呢？下面有请霍博智能 CTO 柯岩先生再来分享洞察产业深处需要什么样的计算机视觉。
大家好，我叫柯岩。今天这个演讲呢会用英文讲，我先解释一下。我是小时候7岁去美国的，所以我还没有读书去了。我的英文其实比我的中文好，所以像这种大会我就用英文。We now live in a world where AI is shaping every aspect of our lives. Not only is it improving our personal lives, it's also improving the business processes of enterprises. The reason why machine learning is taking off is because every aspect of the physical world is being digitalized, and the machine learning algorithms have vast amounts of data to learn and process and improve the algorithms. I've always loved to work on V1 products, and through machine learning, there's a never-ending supply of challenges and problems that can be solved through machine learning. Today I'll be talking about how to digitalize the physical world through computer vision. And one of the first forays into digitalizing the physical world was when I started at Microsoft in 2008, I think. I worked on things knowledge search, knowledge graph. And what we built was a crawler that can extract facts and knowledge from the web. Instead of indexing the text as words, we parsed the sentences, understood it through natural language processing, and we stored all of these facts in the knowledge graph. Through the knowledge graph, I built an algorithm where we can display facts and answer questions about the world. For example, you can ask about the longest rivers in the world, and Bing would give you the list of rivers instantly without having the user digging into every web page. It sorts the rivers by length, and the user can instantly see the results. It was a lot of fun working on these types of problems at Bing, but what I realized was there were lots of other businesses and enterprises that could benefit from machine learning. They didn't have the luxury that we had at Bing, where we had hundreds of machine learning scientists working on a problem. At most, they had one or two looking at these problems. And so what I thought was, how do we bring machine learning to these other businesses as well? One natural place for me to go would be to Silicon Valley, where there's a rich tech environment. The other place with booming innovation is China. And back then, products like mobile payments, O2O, were well ahead of the US. With well-funded VCs and a culture of innovation and risk tolerance, I decided that China would be the next step for me. At that time, drones were taking off, literally, the entire industry. There were hardware manufacturers racing to build drones that could fly farther and longer, and with high-resolution cameras that can take clearer pictures. There were software companies building drone analytics platforms, trying to analyze all of the imagery taken from the drones. I decided that the drones and value that they create is in all of the data they can capture. And so I and 3 other Microsofties decided to create Clobotics. Started in 2016, our mission is to paint an intelligent world through vision. To do that, we first must digitalize it. We first must digitalize the physical world before the machine learning algorithms can be applied, before the computer vision algorithms can be applied. In the past 2 years, we've grown to over 100 employees, full-time employees, and we have dual headquarters in Shanghai and Seattle. We have offices spanning 3 countries, and we have branch offices in Dalian, Singapore, and Beijing. With our extensive experience in cloud, in B2B, and computer vision, we decided that we could actually build these solutions. We could actually help the enterprises digitalize their assets. When we first started, we thought that we would be building a drone platform where the thousands of drones up in the sky would send all their data to our data centers, where our machine learning algorithms and computer vision algorithms can analyze and process the data for them. There was only one small problem. These drones were very difficult to pilot. A lot of businesses, when they looked at drones, they thought that there was potential. They would buy a few drones, they would test them out, but in the end, they would just set them aside because they didn't have enough qualified pilots to pilot them. They couldn't accurately control the drones to capture the images that they needed to process. They didn't have a way to digitalize their assets with the drones. And a core part of a machine learning company, an AI company, is data. And without data, we wouldn't be able to scale our businesses either. And so what we decided was that we would build an end-to-end solution for our customers. We would build a hardware and software solution, and on top of it, we would apply machine learning algorithms. We would help our businesses digitalize end-to-end. We looked at a number of industries early on, for example, telecom, construction, wind power, solar power, and we decided that we would focus on one specific industry. Many AI companies nowadays are building AI platforms, are building platforms that are generic to everything. What we found was that if we only solve one part of the problem, the customers won't be able to get the data. It's not the case where if you build it, they will come. And so that's why we decided to focus on this one industry. Let's zoom in into the wind turbine inspection business. Annually, it's about 25 billion operations and maintenance market. In China comprises about a third of the entire wind industry market, and it's the fastest growing country in the sector. Overall, there are about 450,000 wind turbines out there on land. Most of them are on land, some are offshore. And so at $25 billion, even this very niche market, seemingly very niche industry, is a huge market, especially for a startup. Let's take a look at why the O&M, the operations and maintenance of these wind turbines are so expensive. Traditionally, engineers had to climb up to the wind turbines using ropes and ladders, and they have to bring expensive equipment to do the inspections. Typically, it takes about half a day, a crew of 4 people, to do an inspection of a turbine. They had to do this about twice a year, and so you can imagine the cost here. What we decided was that we could automate this process. We could make it much faster, cheaper, and safer through the use of drones. We created an 100% autonomous solution to capture data and to inspect the turbines. You can imagine that this is an L4 autonomous driving in the air. The drones do not need any sort of manual control to operate. The drones fly about 10 meters away from the turbines, and it can capture high-resolution images, and it can finish in about 30 minutes. Let me show you a video of one of our customers piloting the drones. They had minimal training, so they took about a 1-hour training course to learn how to fly the drone, as opposed to a traditional drone where it would take a lot of experience, many hundreds of hours of training before they can pilot safely. And so this video shows a drone in action. You can see that using a pad, the customer presses a single click on the pad and the drone will automatically take off and take pictures. The drone is like an autonomous car in many ways. It has a LiDAR, it has a camera, it has onboard computing, and we have algorithms, we have flight control algorithms that fuses all of these sensors together to build the algorithm and to fly. We don't need any sort of customization on the turbine. So there are actually many types of turbines. The turbines are made by different manufacturers. There are different sizes, heights, widths, and lengths of the turbines. But because our drone is able to sense the turbine automatically, we don't need any sort of custom control parameters to do it. It's able to sense where the turbine is and track along it. We call this one-click digitalization of the physical world. So, a core part of what we built is the flight control. The flight control needs to be able to accurately track the blade in order to take pictures of it. And so on the left here is a raw video of our turbine, of what our drone sees. On the right is the output of a machine learning algorithm showing that it has detected and segmented the blade. You can see that even though the blade is moving around in the view, and sometimes it goes off view, our algorithm is able to accurately track it. And so this is a core part of it, to be able to accurately track the turbine so that we can take the pictures. Let's take a look at some of the advantages of the drone. Why using drones is so much easier and faster than traditional inspections. So for one, we're about 10 times faster and 10 times more efficient than traditional inspections. So traditional inspections might need 4 people half a day to do a single turbine. Using our drone, we can complete an inspection in less than 30 minutes using one person. And so one person can cover many more inspections. In terms of the resolution and quality of our inspections, we can detect cracks at 1 millimeter by 3 millimeter. And just to give you a visualization of what this means, on the left here is a picture that we took of a turbine, the drone took. On the right is a zoomed in version of that picture. You can see that you can actually see the legs on the fly. This is how accurate and how precise the pictures are. So why do we need this? Why do we need to be able to see this millimeter specs on the turbine? A typical turbine takes about $1 to $2 million to install. Manufacturing installation fees about $1 to $2 million. To replace a single blade takes on the order of about 100,000 US dollars, several hundred thousand dollars. But on the other hand, if you do a minor repair, it might only cost a few $1,000s. And so that's why it's important to do these inspections frequently, and so that we can find these minor details, so that we can do the repairs before it gets severe. This leads to an overall reduction in the operations and maintenance of these turbines. Here are some typical pictures that we see of these turbines. These are some typical defects. Some of them are caused by lightning strikes. So the ones at the tips of the blade, these are caused by lightning strikes. But on the second picture here, this is a very typical erosion from the turbine. And you can see that's always on the leading edge. We see this on almost every single turbine that we inspect, these type of erosions. And over time, if you don't repair them, they'll grow, and eventually the blade will need to be replaced. And of course, we don't want to replace the blade, we want to do these small repairs. So why do these defects occur? If you look at the turbines from far away, it might look like they're spinning very slowly. They're spinning at about a few revolutions per minute. But these turbines are huge. These turbines are about 100 meters tall. And the lengths of these are between 50 and 80 meters. So a single blade is about 80 meters long. Some of the offshore turbines are even longer. The offshore ones are over 100 meters long. If you calculate the linear speed of these turbines, it's going at about 300 kilometers an hour. 300 kilometers, so that's about as fast as a bullet train. And they're spinning 24 hours a day, 365 hours, 365 days a year. If you multiply this out, this is about the distance to the moon and back 3 times a year. So we're making 3 round trips to the moon every single year. That's how fast these turbines are moving, how far they're moving. And so all of the sand, the dust, the rain that's hitting the blades will cause erosion. And so we need to do these maintenance and repairs. Let's compare how the inspections are traditionally done and what kind of reports that we can provide. On the left here is an inspection where somebody climbed up to the blade using a rope and ladder, and they took a picture and they labeled it through a piece of paper. That piece of paper says, turbine number 35, blade A1. That's all the information that we get from a traditional report. We don't know how severe the defect is. We don't know where it is.